Right. So when you talk about construct validity, what exactly is construct validity? Construct validity is that, whatever psychological phenomena or whatever psychological variable that you wish to study, right? You try to look at, you develop a test and you try to look at how does it do in relationship to the other tests on constructs that are in some way related to your particular construct. Now, what does that exactly mean? Let's say you want to develop a test on self-esteem, right? Now, you develop this test and you look at all of these different, other different tests that are in the domain. Now, what could be relevant to self-esteem? What do you think? So perhaps, when you just think about constructs, or when you just think about psychological constructs, right? Some of the psychological constructs that may come to your mind when you think about when you think about self-esteem might be something like locus of control, perhaps, right? It might be self-efficacy, which is basically this belief that you have what is necessary, or basically an understanding of your own abilities, right? What else would self-esteem be related to? So it could be, now these are things that it could be related to positively, right? So you'd expect that someone who has a high level of self-esteem would have a more external locus of control or higher self-efficacy, right? Let's forget about locus of control. A lot of you might not know what a locus of control is as yet. So let's say that, someone who has self-esteem, high self-esteem, would have higher self-efficacy, which is basically understanding one's own abilities or having belief in one's own abilities, right? What could self-esteem be negatively related to? It could be negatively related to, what could be a negative construct when you talk about self-esteem? Right, so one of them could be something like anxiety, right? Social anxiety, right? Someone who has high self-esteem might have lower social anxiety, right? Now, when you develop a test for self-esteem, you could correlate this test with a test that's already developed for self-efficacy and see the relationship there. And you could also correlate it with a test that's already developed for social anxiety and test there. And, this should have a negative correlation and this should have a positive correlation. So this is what construct validity looks like. Let me show you a diagram as well, which might, help you understand this better. So here you have this diagram which basically outlines how construct validity works. So let's say you come up with, this sort of scale which checks for extroversion, which is, it's a dimension on a personality scale. It basically looks at how open you are, to sort of how extroverted you are, in the sense that, how it's basically this dimension of extroversion versus introversion, right? So how much do you like, let's say, going out or being around other people, how open you are to meeting new people, right? So all of that is sort of included in extroversion. So what you see here is that this has a positive correlation here with sociability, right? Again, wanting to interact. With self-acceptance, a moderate correlation, right? With extroversion on another scale, right, which is the MPI, there is a high correlation, right? On tolerance, there's just, almost no correlation, very low correlation. Then you have here what social introversion, right? So obviously introversion would have a negative correlation. With social discomfort, negative correlation. With neuroticism, which is again another dimension on personality scales, which looks at how sort of volatile one's moods are. So that would be, or it's something, neuroticism is something that's termed negative emotionality. So again, extroversion is negatively correlated with neuroticism. So basically, this is how you calculate construct validity, that you create this sort of, diagram in which you show how the constructs that are related to it, what their correlation coefficients look like, and the constructs that seem to be opposite to the construct that you're interested in, what the correlation coefficients look like here, right? So this is what construct validity is about. Right, so moving on from this, in our next section, what we look at is the history of intelligence testing and how that's evolved, right? So when we look at the history of intelligence testing, the first person that we consider is someone called Galton, Francis Galton, who was a cousin of Charles Darwin. And what we see is that Galton made contributions to intelligence testing in the sense that he started the movement of testing and sort of, what we call normative testing now. But his ideas of what intelligence testing constituted of are no longer relevant, in the sense that he belonged to a very empiricist way of thinking about things. He believed that whoever has the best senses would be the most intelligent. So because the empiricist way of looking at things is that knowledge comes from the senses, right? So Galton believed, arguing thus, that whoever has the best senses, right, whoever can, let's say, whoever has very sharp eyesight, right, they will have, or whoever has all of the different whoever can hear or discriminate between various tones, right, very, very effectively, is the most intelligent. So whoever has the best senses will be the most intelligent. That's how Galton was arguing. And he basically collected data from a whole lot of people. But this is one of the things that we see, that this premise is no longer acceptable. What you see from evidence when you conduct research and when you look at people's intelligence and you look at their sensory abilities, because this is what he was looking at. He was looking at sensory abilities, right? So it's not necessary that this has a very high correlation with how intelligent they are, right? But Galton sort of started this movement in which he started measuring for intelligence, and then that was taken forth. The next person that we talk about is a Frenchman who's called Alfred Binet. So Binet basically was commissioned by the government of France to sort of formulate a test which could sort of help them discriminate or tell in an educational setting what children needed special education, right? So Alfred Binet set out with this task of forming the sort of test which would help educational institutes figure out which children needed special education. And Binet, what he did was that he put forth a test, and he was again sort of, what he did was that he formed a test. He gave it to, let's say, a couple of 6-year-olds, right? And what he saw was that if 90% or a considerable percentage of those 6-year-olds could attempt that test and attempt it successfully, then that meant that a typical 6-year-old must be able to complete these many tasks on a particular intelligence test, right? Let me go over that again. So what he did was that he developed a test, right? And he, let's say, gave it to a couple of 6-year-olds, right? And what he saw was that 90% of those 6-year-olds could answer correctly on 90% of the items on that test, right? Let's write that down. So 90% of 6-year-olds could successfully score on 90% of the test, right? Whereas if you gave that test to 5-year-olds, they could not, 90% of the 5-year-olds could not score 90% on that test. So he said, let's say that, this is basically this sort of scoring, or this sort of result, right, is typical of a 6-year-old, right? So let's say if you give this test to a 6-year-old and who cannot score 90% on this test, then that means that they have the chronological age of, let's say, a 5-year-old, or they don't have the chronological age of they do not have the mental age of a 5-year-old, of a 6-year-old. Sorry, let's just, okay, so that might be very confusing. Let me sort of rewind that a bit. So basically what Binet did was that he differentiated between what he called the chronological age, right, and the mental age, right? Now what does that mean? So basically, again, let's say he gave this test to 6-year-olds. 60% of the 6-year-olds could score 90% of the test, right? They could answer correctly on 90% of the test. So Binet concluded that this performance that they could, score on 90% of the test was typical of a 6-year-old, right? So any child of any age, right, you give them this test, and if they're able to score 90% on the test, then that means they have a mental age of 6 years, right? Now their chronological age could be 5 years, right? Let's say there's a 5-year-old, you give them this test and they can score 90% of that test correctly. They can score beyond their age in that manner, right? So their chronological age or their biological age is 5 years, but their mental age is 6 years, right? Let's say there is a 4-year-old, and again, same scenario, you give them the test, they can score 90% of it correctly. This is typical. Scoring 90% on this particular test correctly is typical of a 6-year-old, which means this 4-year-old has the mental age of a 6-year-old. So again, the chronological age and the mental age are given thus, right? Let's say you give this test to an 8-year-old, right? And they are not able to score 90% on the test. So their chronological age is 8 years, but their mental age might be 5 years or younger. Does that make sense? So basically what Binet did was that he developed a test, right? And he gave that test to children of different ages. And what he noted down was what was the typical performance of a child of a particular age. So if you gave it to a 4-year-old, how did a typical 4-year-old perform? How did a typical 5-year-old perform? And when he, got these results, he formed what was the mental age and the chronological age. So, using these results, he formed this sort of system in which he could place any other student who was taking, any new student who was coming and taking the test, he could place them within these mental ages, right? So let's say on that particular test, an 8-year-old could score, 90% of the items correctly, right? And if a 6-year-old comes in and they're able to also score 90%, then that 6-year-old has the mental age of a 8-year-old, right? So this is how the system of Binet's was working. After Binet, Terman, who was another person who was working on psychological testing, came along and he made some revisions to this test that Binet had put forth. And after those revisions, the test came to be known as the Stanford-Binet test. Right, the revisions that Terman made were basically that he put forth a formula, which was that, the way that you calculate IQ is that IQ is equal to mental age over chronological age, and this was multiplied by 100. So let's say, there was a child who showed the mental age, let's say, of a 9-year-old, right? And their chronological age was 6 years old. So this is how you went about it, and basically you calculated their IQ from here, right? So what would be the IQ be if you have this formula? If you calculate this comes out to be 150, right? If, let's say, you have another child who is 8 years old, their chronological age is 8 years, and their mental age is also 8 years, what would their result be? So you would have here IQ is equal to 8 over 8 into 100, and that comes out to be 100. So the average was always 100, right? According to Stanford Binet. So this is the revision that Terman came up with, right? Next, what we see is that, there's another person whose innovations we consider and who goes by the name of Weschler. So what Weschler noticed was that all of these intelligence tests that we've discussed, right, they were geared towards children. So he basically worked on developing a test which was for adults, right? And there was another revision that he made, which was that before this, a lot of items that were on intelligence tests constituted of looking at verbal performance or verbal IQ, right? He included what was a non-verbal scale for looking at intelligence. Now let's look at an example of that. So, here you have the example from a Weschler adult intelligence scale. You see here that this is the verbal scale, right? So it can have questions such as, what does audacity mean? On what continent is France? Why are children required to go to school, right? How are a calculator and a typewriter like? And then you also have the non-verbal scale, right? Which is the performance scale, which has questions such as, you have these sort of shapes here which are numbered a particular way, and you have to fill in all of these different blanks here. Then you have the picture of a windmill here. You have to tell what's missing. You have to assemble blocks to match this particular design that you have here. And you have to, you have these pictures here. You have to put them in the right order. You have to assemble the pieces here into a composite object. So this was the non-verbal scale that Weschler added, right? When we talk about these innovations, we also talk about, what intelligence tests look like today. So what intelligence tests look like today is like, basically you have a verbal component and you also have a non-verbal component. Now, when you come to discussing, whether, so this is an important question. When you talk about, do intelligence tests measure potential or knowledge? So what do you think? Ideally, intelligence tests measure potential. They want to, look at how well you think on your feet rather than looking at, what you already know. However, when you look at intelligence tests, so, you just saw Weschler's adult intelligence scale, right? What you see is when you, for example, look at, let's say, even on the performance scale, when you look at this picture and you say put the pictures in the right order. Now this requires some knowledge of what is going on in this picture. Even this question requires some knowledge of what a guitar is, right? Let's move towards the verbal scale. It's all the more apparent here when you say what does audacity mean? That requires some previous knowledge. When you have a question like on what continent is France, again, that requires some previous knowledge of geography. So basically, even though ideally intelligence tests measure potential, what you see is that intelligence tests actually measure potential and knowledge, right? So that is something that's important to remember. Coming to some other questions, such as, do intelligence tests have adequate reliability? Because you don't want to get extremely varying results with intelligence testing. What you do find is that when you use, the retest method, what you do find is that intelligence tests in particular do have high reliability, right? What about validity? Now that's, a question which is a little bit more tricky, because validity, there can be different ways of thinking about validity. So do they have adequate validity or not? Now, one of the things that intelligence tests are accused of is that they only focus on one particular dimension of intelligence. What does that mean? So basically, so Sternberg is another, psychologist, and he did some research in which he and his colleagues went around and they asked people who they consider to be intelligent behaviors, what they consider to be intelligent behaviors. And when they compiled that list, what they found was that people usually, think of all of these different facets of intelligence, right? So they, they sort of could categorize all of the different sorts of behaviors that people said were to them seemed, people, whatever they considered to be intelligent behaviors. Sternberg and his colleagues categorized them into these three main intelligences, right? So the first of that is verbal intelligence, which is basically constitutes of speaking clearly and articulately. You're verbally fluent, you're knowledgeable about a particular field, and you can read with high comprehension. You have another domain, which is practical intelligence, that you see all aspects of a problem. You size up situations well, you make good decisions, you pose problems in an optimal way. When you come talking about social intelligence, you have accepting others for what they are, you have, high social conscience, you have, you think before you speak, you are sensitive to other people's needs and desires. Now, what do you think? Intelligence tests mostly only look at this one domain of intelligence. They do not so much look at practical intelligence or social intelligence, right? So in that way, do intelligence tests have adequate validity? That becomes a much more complex question. You can then think in terms of, do intelligence tests predict academic success? And, because most intelligence tests are sort of formulated in academic settings, what you see is that there is a high degree of relationship of intelligence tests with academic success. You can ask another question that, do intelligence tests predict vocational success, or how well will you do in your career? Now, that depends on what sort of career you have, but overall, the answer to this again is yes, there seems to be some correlation between how well you're doing on your job and your IQ test results. Obviously, the more complex your, job is, the more predictive your IQ score will be of your job performance. The closer or the higher the relationship will be between these two, right? So, having said that, let's move on now to another area which looks at, what aspect of intelligence is inherited, or what are some of the influences that we see on intelligence, right? In our discussion on this, one of the things that we look at is, when we're talking about how heritable a particular characteristic is, what that means is how much of a genetic role is there in, and are developing any characteristic, right? So one of the ways that we look at that is by looking at, the genetic overlap and then the relationship in that particular aspect, right? So we see that, identical twins have 100% genetic overlap. They're identical, their DNA is the same, right? And what we see is that for identical twins, the relationship between their intelligence, right, is the highest, right? When we look at identical twins reared apart, now basically identical twins, even though they have 100% genetic overlap, there's also a possibility that identical twins, because they're the same age, they look extremely similar, the environment that they're provided with is very same as well. They're brought up in the same house, right? They're given the same sort of books, they go to the same sort of school, right? So identical twins reared together, the relationship between their intelligences is the highest. When you look at them being reared apart, the genetic overlap is still 100%. What has changed now is the environment, right? And the decline that you see here is because of the change in environment, right? This decline that you see. When you look at fraternal twins reared together, they shared 50% of the same genes, right? This is still lower than identical twins reared apart, right? So this seems to again sort of hint towards genetics, that these are fraternal twins, they have less of a genetic overlap than identical twins, and they had the same environment, but their correlation coefficient for how similar their intelligence scores are is lower than that for identical twins who are reared apart. Then siblings reared together, right? Now, siblings and fraternal twins share the same DNA overlap, right? But siblings reared together have a lower relationship between their IQs. Now, that can also be because fraternal twins are reared, they're the same age, whereas siblings can be different ages, and because of different ages, they might be subjected to very different treatments around the house, right? So that can also be, this is again a case for environmental influences. Basically, what we're trying to look at when we try to look at the heritability of a particular characteristic, we are basically looking at the nature versus nurture debate, right? How much of a particular characteristic is due to genetics, how much of it is due to nurture or the environment. Then you have siblings reared apart, and again the relationship is low. Biological parent and child who live together, this is what the relationship looks like. Biological parent and child lived apart. Adoptive parent and child lived together, this is almost the same as biological parent and child who lived apart, right? But it's still lower than biological parent and child who live together. One of the reasons could be that if children are adopted, one of the reasons obviously can be that you can say intelligence is something that's more heritable. That's one of the things that you see here if you compare this with this, right? Another explanation can be that adoptive children have to see some sort of adversity, that they were taken away from parents or the parents died, and that could also have an impact on their intelligence. Adoptive siblings reared together, no genetic overlap, right? And this is the relationship. So even though there is 0% genetic overlap in both of these cases, you still see a considerable amount of correlation, right? And that does make a case for the environment. Then you have cousins reared apart, and that's a very small correlation. So these are basically we see here that the environment is important. Again, we see here that the environment is important. So it seems to be a combination of nature versus nurture rather than just being nature and just being nurture. That's what you're looking at this graph as well. That's one of the things you can conclude. You could say that genetics perhaps has more of a more of a role, but it's really a combination of genetics and the environment.